All right. Today we're going to do lesson 1.3, solving equations with variables on both sides. So if you look at the top of your notes, you see the exact same sentence that you saw yesterday. Don't call me after midnight. Now, as a review, let's go over what each of those letters stand for. If you don't remember, where can you find the answer? In yesterday's notes. All right, very good. So here we go. The D stands for what? Distributive property. Okay. The C in call stands for what? Combine like terms. Now remember, this is really important. When we are looking to combine like terms, where do they have to fall? The same side. All right, the same side of the equal sign. Then we move on to the M. Don't call me. What does the M stand for? Move the variable. Now yesterday we didn't have that, right? We kept skipping that step because we didn't have a variable on both sides. But all of that changes today, as you can see by the title of lesson 1.3, solving equations with variables on both sides. So today you are going to have variables on both sides and you are going to have to move one. Now where are we going to try and move the variable? To which side?
Left side.
The left side, okay? Again, this doesn't make our answer right or wrong. This helps eliminate an extra step at the end since I like the variable on the left side of the answer, okay? So we're going to do our best to move that variable to the left side, all right? Then it's after. What's the A stand for in after?
Addition.
Add or subtract. Very good. We move the number that needs to be moved with addition or subtraction. And midnight. What's the M stand for? Multiply or divide. So we're going to move the number that needs to be multiplied or divided. Now, the essential question, how can you solve an equation that has variables on both sides? You'll notice I didn't put everything that you see on the screen into your notes again. I just put the sentence. Why? Because you have all of that information in lesson 1.2 notes. So you can always flip back there if you need it. Now, what do I do when the variable cancels out? This is a new situation that we're going to see today. We're going to be solving, we're going to be working through Don't Call Me After Midnight, and sometimes that variable is going to go away. So here's what happens. When the variable cancels out and the statement left is a true statement, the answer is infinitely many solutions. Okay? You might remember it as infinite solutions with Mrs. Kinder. Okay? For the purpose of filling in your notes, write infinitely many solutions. When it comes to answering the questions, I will accept infinite solutions. All right? But I also want you to highlight true and infinitely many solutions. That's what I want to stand out. If the variable cancels and your statement left is true, your answer is infinitely many solutions. When the variable cancels out and the statement left is false, the answer is no solution. So fill in that blank and highlight false and no solution. Now, let's just practice this a little bit. Let's say the variable cancels and you're left with 7 equals 0. Is that a true statement? No. So what would your final answer be? No solution. Very good. Let's say the variable cancels, it goes away, and you have 6 equals 6. Is that true? Yes. So your final answer would be infinitely many solutions or infinite solutions. All right? So just keep this in mind. So when we reach that type of problem, you know what to do. All right? Now, it says solve the equation if possible. The reason it says if possible is because of what we just discussed. If the variable cancels out, it's not going to be possible for us to solve for that variable. So that's the only reason why it says if possible. We're still going to follow the process of Don't Call Me After Midnight. All right? So look at letter A. Distributive property. Do you see the distributive property in letter A? No. All right, which leads us to step 2. Do we have any like terms to combine? No, because remember, combining like terms means they're on the same side of the equal sign. If you look at the left side of the problem and then you look at the right side, there are no like terms on the same side of the equal sign. So that moves us into move the variable. All right? Now, take your highlighter, and this is what I want you to do. Highlight the variable terms that you see in this problem. Highlight the variable terms that you see in this. What are the variable terms in this problem?
2x, negative 2x, and 3x.
Negative 2x and 3x. So you highlighted those. Now, take your pencil And don't draw too big or too small, but draw you a line through the equal sign just so you can see the two sides of the problem. Because if you're trying to decide if you have to move a variable, you got to figure out if there's a variable on both sides of the equation. So very clearly we can see, is there a variable on both sides? Yes, so we got to move one. All right. Which one, if we're trying to move our variable to the left side, which one do we need to move? Good. Now be very careful. We're moving the entire term. So we are moving it with addition or subtraction. Never multiplication or division, because we're taking the 3 and the x. So how are we going to move 3x to the other side? Good. That is a positive 3x. So we are going to subtract 3x from both sides. So it cancels on the right. What's negative 2x minus 3x? Man, I hate when I give the answer. Negative 5x. Bring down what we have not used. So equals 10. Now, there's nothing to add or subtract. So what's the last step to solving this? Perfect. Divide both sides by negative 5. Those cancel. And so x equals negative 2. Keep in mind, you can always check equation answers. Plug them into the original problem. See if your problem comes out to be true. All right, now let's talk about B. B is going to cause us a little bit of discussion because of something I taught you yesterday. What do you see right off the bat we're going to have to do first? Distribute, right? The distributive property, because there are parentheses. But what needs to be distributed in this problem? Fraction. Now, if you remember towards the end of yesterday, I taught you that instead of distributing a fraction, how could we get rid of it quickly?
Multiply both sides by the reciprocal.
Multiply both sides by the reciprocal. And I still hold to that. Okay? If you want to get rid of the fraction quick, you're going to multiply both sides by the reciprocal. In this problem, what would the reciprocal be? 2 over 1 or 2. Okay? So, here's the only thing that you have to be careful of. If you remember yesterday, when we multiplied both sides by the reciprocal, the other side of the equation only had one term. So it was real easy. Okay? But look at the other side of this equation. How many terms does it have? 2. And if you're not careful, you won't multiply both of them. If you're going to multiply both sides by 2, you have to make sure that both negative 5h and the 1 get multiplied by 2. So if you feel like that's too much for you to remember and you might forget, all right, think about this as well. Yesterday's fractions were 3/10 and negative 6/5. Okay, those weren't real simple fractions. This is a half. What's half of 6h? Okay, so my personal opinion, if I see that I'm distributing a half, I'm going to go ahead and distribute because I can do this quick. Half of 6h is 3h, bring down the minus sign. Half of 4 is 2. So it's almost easier in this instance to just distribute that half. But again, if you want to multiply both sides by the reciprocal, go for it. It'll work. You just have to remember to multiply both parts, both terms on the right side. Now, go ahead with that highlighter again and highlight variable terms. Highlight variable terms and then draw your line through the equal sign. What are the variable terms in this problem? Good. So again, do we have a variable on both sides? Yes. So we're going to have to move one. Which one do we want to move? Good. We're trying to get the variable to the left side, so we're going to move negative 5h. How? We're going to add 5h. Now, why am I adding 5h to 3h and not the negative 2?
Because they're not the same.
They are not like terms. Very good. So 3h plus 5h is 8h. We bring down what we have not used. Negative 2 equals 1. All right, what would be the next step? Add 2 to each side. So 8h equals 3. And last but not least, we would divide both sides by 8. Now, I have one more question. Since this whole problem has been us discussing, let's talk about what if, instead of moving the negative 5h, you moved the 3h. Let's say you forgot that we were trying to move the variable to the left, and so you moved 3h to the other side. Do you think you would come up with the same answer? Yes, okay? The only difference would be your problem would read 3/8 equals h. And based off of Miss Johnson's preference, you would then have to rewrite your problem, okay? Rewrite your answer. So all I'm doing by having you move the variable to the left is I'm saving you an extra step at the end, all right? So this, again, is just my way of trying to help you out a little bit. But if you were to move the 3h to the right, you still should come up with the exact same answer, okay? Now, look at letters C and D. Before you try not to read the sentence that I've written yet. Let's talk about C and D. Do either of those require us to do the distributive property? No. Do either of those have like terms for us to combine? No. So we're at move the variable. Do they have a variable on both sides of the equation?
Yes.
Okay. So I've been teaching you move the variable to the left. So let's say you like that and you're going to keep that's how you're going to do it. You're going to move it to the left. Okay? What happens if I move 6y to the left side in letter C? There's going to be nothing left on the right side, and that is not what we want when we're solving an equation. All right? Especially when we've just started to solve the equation. So look at the sentence I've written and highlight it. If moving the variable to the left side will leave the side blank, don't do it. I don't want you to. Because then you're going to get confused. You're going to create extra work for yourself, and that's not what I'm trying to do. All right? So with that in mind, I want you and your partner to work letter C and letter D. Jordan, if we move, how did you move 6y to the other side of the problem? Well, you have to, because remember I'm sorry, you're right. So you moved 9y. How did you move 9y?
I added 9y to 6y.
Good job. I was making sure you were paying attention. I was just kidding. I messed that one up. Okay, so we're going to add 9y. Oh, I forgot to make it right. Sorry, guys. All right, so you added 9y to both sides, correct?
Yes.
Perfect. So it canceled on the left. 80 equals 15y. How did you finish this? Divide both sides by 15. So y equals, what did this reduce to?
16 over 3.
16. And say that again. What did 80 over 15 reduce to?
16 over 3.
16 thirds. And remember, we want the variable first, so we just got to rewrite it as 16 thirds. All right? Miles, what did you move? What did you and your partner do to letter D? Which variable term did you move?
The 4.
How did you move? Well, give me the whole term. You didn't just move the 4. You moved the 4x. Good. How did you move it?
You added it.
Okay, you add 4x to both sides. So it cancels on the left, and 10 equals?
Negative 5x.
Good. And how did you finish this one?
You divided 5 both times.
Good. Divide both sides by 5, and so x equals?
Negative 2.
Good. Again, because I want the variable first. Now, I had this question asked me in second hour, and I okayed it. So as long as you show me this step right here, as long as I can see that you divided both sides by negative 5, all right, and I can see that you crossed out the negative 5s because they equal 1 and we don't need that, you can actually go ahead and go to the final answer if you would like, okay? So if you'd like to eliminate this step right here, my main concern is that I can see your work, okay? I understand that you divided both sides by negative 5, you canceled the negative 5s. I'll let you go straight to that final answer if you want to, okay? Now, look at letter E. What do we see really quickly that we're supposed to do? Distribute property. So let's distribute. And what do we get when we distribute the 4? 4 minus 4p. Perfect, okay? We bring down what we haven't used. Do we have any like terms to combine?
No.
Do we have a variable we need to move? Yeah, what do we need to move?
Negative 4p.
And how are we going to move negative 4p? Now, it really doesn't matter which one we're moving because they're both negative 4p's. So what happens when you have negative 4p plus 4p? It cancels. It equals 0. It goes away on both sides. So you are left with 4 equals 4. Now here we are. We have no variable anymore. So the question is this statement true?
Yes.
Yes. So what's my final answer? Infinite solutions. And like I said, I'm okay if you don't do infinitely many and you just want to do infinite solutions. Okay? But please never box in 4 equals 4. That's not your answer. Because it's 4 equals 4, there are infinite solutions. That means I could put any number I wanted in that original problem and the same thing's going to come out on both sides. All right? Now, for those of you that like shortcuts, for those of you that see things different than other people, did any of you notice after we distributed what you had on both sides?
Yes.
What did you have?
4 and 4 and 4.
And?
4 and 4.
So you had the exact same thing on both sides of the equal sign, correct? So you could have stopped right there and told me infinite solutions was my final answer. Okay? Now let's talk about it. It has to be identical. That is because every number has a sign. The sign's directly in front of it. This is a positive 4 and so is this. This is a negative 4p and so is this. So even though they're written in a different order, they are identical. If even one of those things had been different, you would have had to keep working the problem. Now, you're thinking, Miss Johnson, I don't get it. You lost me. It's okay. Follow Don't Call Me After Midnight and you're going to get to the right answer. Okay? This is not something you must recognize. This is just for those that do recognize it. If the both sides of the equal sign are exactly the same, your answer is going to be infinitely many solutions. All right? Now, real quick, let's do letter F. What do we got to do first? Distribute. So we distribute the 3 and we get
15x
plus. Now, we can't stop here because the two sides are not identical. So we got to keep going. Is there a variable for us to move?
Yes.
What is it?
15x.
All right. And how are we going to move it?
Subtract 15x.
We're going to subtract 15x from both sides. So again, both cancel. Now 6 equals. Normally, I don't make you bring zeros down. But if there is nothing else on that side of the problem, we have to. So we have to bring a 0 down. Because, once again, the variable's gone. So the question is that a true statement?
No.
That is not a true statement, which means our final answer is
No solution.
no solution. Awesome. I want you to go ahead to letter G, and I want you to distribute on both sides. All right, Makana, when you distribute on the left, what do you get?
6a minus 6.
All right, and Zachary, when you distribute on the right, what do you get?
6 minus 2.
Now, this one's even easier to see because it's written exactly the same. Are both sides of the equation equal? So you could stop and write down what as your final answer? Infinite solutions. Now look, I get it. Some of you might still be like, Miss Johnson, I just don't understand what you're saying, okay? All right. If you don't, keep working. You would subtract 6a from both sides. They would cancel. You would get negative 6 equals negative 6, which is a true statement, which would lead you to infinite solutions, all right? But again, hopefully this one's really simple for you to see. They're exactly the same on both sides. All right, and lastly, the most simple word problem you're ever going to see from me this year. You and your friend drive toward each other. The equation is right here. 50h equals 190 minus 45h represents the number h hours until you and your friend meet. When will you meet? So we are literally taking 50h equals 190 minus 45h. What are we doing first? We're moving the variable to the left side. So we're adding 45h to both sides. That's 95h equals 190. And how do we finish this off? Good job. Divide both sides by 95. So h equals what? 2 hours. Very good, whoever gave me the answer and the label. Don't forget to label it. It's still a word problem. It still needs a label. And that is lesson 1.3.